My name's John Llewellyn. I've been involved with flat roofing for over 40 years at this point in my career. Half this time installing various types of flat roofing systems, including mastic asphalt, bituminous membranes, liquid roofing and single ply, and the other half working for Bauder, creating specifications, helping a team and various teams over the Midlands, North of England, Scotland and Ireland to deliver successful flat roofing. I have got a passion for diagnostics and providing appropriate roofing solutions and maximizing the performance of our next generation flat roofing projects. Well, more and more owners, building owners, are considering their plans to achieve net zero carbon emissions and of course manage rising costs of heating and cooling. So there is growing interest in the thermal performance of a flat roofing system, as well as the condition of the waterproofing. Today, we're covering advanced surveying techniques, the impact of trapped water within an insulated warm roof, when to overlay or totally remove an existing roof area, and understand the potential energy and carbon savings offered by upgrading a flat roofing system. Now, just to set the scene here with regard to why we are using these advanced surveying techniques, just a quick anecdote. Our chairman, Paul Bauder, often jokes there are two types of flat roofs, those that are leaking and those that are not yet leaking. Of course, he's talking about water ingress, but there is also a third type to consider, roofs that leak energy out of the building, not water in. These advanced surveying techniques demonstrate the actual cost of these such defects. This survey identifies energy loss through poorly insulated roofs and wet insulation. The information provided guides the specification to include either an overlay approach or a complete strip off to the roof deck. This avoids trapping in saturated insulation that could affect the thermal performance of the new waterproofing system, or worse, trapping moisture that will have a detrimental impact on the fabric of the building. But importantly, it identifies the most significant gains in terms of energy and carbon savings on flat roofing projects. Firstly, a look at the equipment. Not to be confused with electronic leak detection, these two scanning devices are the best available for measuring moisture, but they actually measure very different things. On the left, the electrical impedance meter is measuring how electrical current passes through materials, whereas the device on the right is a nuclear density gauge. It's actually measuring the density of materials. The electrical device has a needle dial and the density gauge displays a numerical reading. It's usually from 0 to 120. But in both cases, the more moisture, the higher the readings. Looking at the electrical impedance meter first, this device works really well on single ply or single layered bitumen membranes. It has a limited penetration on dense buildups, for example, mastic asphalt or multiple layers of bitumen roofing. And it can be confused by conductive materials. So for example, we're seeing more and more metal foil facing used on insulation products or within membranes for air and vapor control layers, damp surfaces, and even some waterproofing systems. For example, polyurea is highly conductive, and that confuses this type of a gauge. However, it is great to use because it's so easy to put it in the boot of the car. Away you go to the roof, take it on the roof, and it works really well. Unfortunately, it's unable to create the moisture maps that I'm going to be talking about during today's presentation. So if you want to produce moisture maps, you need one of these. As I mentioned, it's actually measuring the density, so it works on any type of roofing system. It'll measure down to about 200 millimeters, so it will even detect moisture in wet insulation beneath a dry layer of insulation. So an existing roof that has been overlaid, for example, it will still be able to detect the moisture on the underside insulation. Disadvantages though, there are very strict rules to govern the storage, transport and use of this device. licenses, qualifications, the ongoing administration makes it much more onerous to deploy this service on projects. But the big advantage is that with an experienced operative, this gauge is so accurate that moisture mapping can be achieved. So what are the principles of this type of survey and what are we trying to achieve with it? Well, the objectives are to understand the condition of the waterproofing, but also gain an understanding of the thermal performance and therefore energy efficiency of roof coverings. We then use this information to estimate the potential energy savings and carbon reduction when our proposed roofing solution is installed. This information then guides our project specification to provide the correct roofing solution, including combined solar PV if required. So we take these two technologies and blend them together. And with this approach, we can use the actual existing roof performance uncovered by the moisture mapping survey and combine this with bespoke energy loss software to produce the information so vital for clients to understand the gains in energy and carbon reduction schemes. So trapped water within insulation. Well, many of the projects we moisture map are found to contain saturated insulation. It's actually surprisingly uncommon to find one without areas of wet insulation. These are real examples of extremely serious saturation, bearing in mind that it takes months, if not years, for PIR insulations to become saturated. You might expect that it's only older roofs that suffer with this, but no, we're actually finding that occasionally relatively young flat roof systems are already losing clients and building owners thousands of pounds a year in wasted energy costs. For example, this is a school in the Midlands. It's a 1,200 metre roof area, and the roof coverings on there, they're relatively young, 12 years old, isn't old for a flat roofing system. It was an expensive system to install, tapered insulation on a vapour control layer, and a 2-layer high-performance elastomeric waterproofing. It would have cost in the region of £135,000 to install that roofing system. And we've surveyed it to find that 26% of that roof is saturated. And this defect alone is costing £1,852 a year in heating costs. And it's wasting 12 tonnes of carbon. And that was prior to the recent energy increase prices. So these defects are getting more and more expensive to cope with the lost energy that comes out of the roof area. So we're going to talk now about overlaying or removing an existing roof. And this type of approach, it's more than a visual inspection. To determine if an insulated roof area is suitable to overlay, we need to know really if the insulation is dry on the whole roof area. Even with core samples, it's hit and miss to determine this during a visual inspection. Some roof coverings are suitable to overlay without moisture mapping. For example, if there's no insulation present in the waterproofing system, secure and in reasonable condition, and as long as the roof deck is structurally sound, it's good to overlay. But if there is insulation present, then there is a chance of trapped water that could cause a problem. And on larger roof areas, especially on timber or metal roof decks, the risk should be carefully considered. So when we see this level of saturation, where the majority of the roof area has been compromised, the specification needs to include for the existing roof coverings to be removed down to the original roof deck. And these are two actual projects. However, alternatively, if the majority of the roof is dry, especially when the wet insulation is in a small number of areas, then we can successfully overlay this existing roof. As long as the waterproofing is also suitable to receive the new system, we simply remove the wet insulation in the zones that are defective. So to conclude, if the roof area is generally dry and the affected areas are low in number, then overlay options are available. By removing this wet insulation, it is possible to overlay them. But as soon as saturation has affected over, and we estimate circa 60% of the roof, or if many areas of wet insulation are spread over the entire roof area, then it's unfortunately best practice to strip down to the roof deck. Another real life example here, just to show you of a roof area that's suitable to have a 50% strip off and 50% saving and overlaid with a new system approach. So when considering to overlay or remove moisture mapping, it is a very useful strategy to move forward with. It's because the advanced survey will confirm exactly which areas of the roof are suitable to overlay without guessing. We can then include the dry insulation within the new U value calculations and top up the thickness to meet the current building regulations. This has a cost saving. We also save by minimizing the waste to landfill, and it does all this without increasing the risk. So we gather the results of the survey, and then these are fed into bespoke software, including the all-important before and after U values and the saturation percentage. We then see the saving presented in energy along with the carbon saving in tons. And this data is very valuable to clients who are prioritizing building stock for an upgrade as part of their decarbonisation schemes. Add in solar PV to realize the true full potential of the roof area. With solar PV, the increases in energy prices, we are seeing larger projects have a PV payback period now between 5 and 7 years. The benefits in reducing carbon are there over the lifetime of the roof area, and they are maximized with this approach. So this process, it results in 2 reports. Firstly, a moisture mapping survey report, and then of course, the important energy saving estimate. We would advise first and foremost that all roofs be subjected to a standard roof survey. This is to assess the need for an advanced survey. But the best upgrades in terms of savings come from roofs that are poorly insulated, for example, a 50mm PIR, achieving 0.45 watts per meter squared Kelvin. And of course, roof areas with no insulation at all. Interestingly, when you've got an insulated roof, even if it meets the current building regulations, as soon as you reach a point of where it's 30% saturated, that then also provides some serious savings. So 30% saturation, we look at all roofs to provide this data. And of course, every flat roof, generally of a reasonable size, is capable of housing solar PV systems. So that's an interesting aspect too to consider. The correct roofing solution is critical. We choose that depending on the specific project requirements, depending on the complexity, the functionality of the roof, and of course the budget to provide long-term roofing solution. And we provide comprehensive guarantees that also include the attachment interface between the roofing system and the PV. So thank you very much for the opportunity to share this with you. We have got a technical roof survey resources that can be downloaded from our RICS CPD section of the website. You could alternatively arrange an appointment with one of our area managers. Please contact Bauder to make the arrangements. And we would like to hear more about reducing your carbon emissions and improving energy efficiency on your flat roofing projects. Thanks for your time.